stated, where a0, a1, a2, an minus 1, an, they are all constants or functions of x is called LDE. So first we are going to do where they are constants. On the right side, it should be function of independent variable. What is independent variable? X. Dependent is y. So if they are constants, then such a linear differential equation is called LDE with a constant coefficient. And what is the standard form? Because we have assumed d by dx of d, in view of this notation, we can rewrite the given equation in this particular form. This is what is called standard form of linear differential equation. Now this is an operator. So then if q of x is 0, that is f of d on y equal to 0, this part is called homogeneous part of this LDE. If q of x is not 0, then it is what is called non-homogeneous linear differential equation. So let us see what is Wronskian. We are getting questions based on this and what is the application. We require this concept for getting general solution. If y1, y2, yn are solutions of homogeneous linear differential equation on any interval defined by this, then Wronskian is defined by this. What is the meaning? First row y1, y2, yn. Second row the derivatives. Next row their derivatives. Like that, if you keep on differentiating n minus 1th derivative we take, the determinant thus obtained is what is called Wronskian. And if Wronskian is 0, then we say y1, y2, yn are linearly dependent. If Wronskian is not 0, then y1, y2, yn are said to be linearly independent. So let us see the application of this. So for example here, which of the following are linearly independent? This is helpful, a direct application of that. So you are getting questions based on this. These two are always linearly independent. Linearly independent only when A is equal to B. Linearly independent when A not equal to B. Like this, options will be given. So what are the values of A and B? Is it for all A, B, or what are the constraints on them? So how to check whether they are linearly independent or not? So we use the concept of Wronskian. y1, y2, derivative a e power x, b e power x, dx, ad minus bc, which is b minus a into this. This is not 0 when b is not equal to a. This is 0 when b equal to a. Therefore, y1, y2 are linearly independent when b is not equal to a. When b is not equal to a, this is not 0. Exponential is never 0. So this product is not 0 when b is not equal to a. Therefore, y1 and y2 are linearly independent on any interval provided a is not equal to b. For example, you are given e power 2x, e power 3x. If you look at e power 2x and e power 3x, are they independent or not means you need not do the problem. By looking at this, you can say they are independent because of this. So here 2, 3, they are different. When they are different, automatically linearly independent. So e power 2x and e power 3x are automatically linearly independent. Next, if you take y1 as e power ax, c e power ax, b equal to a. Let us constant times this. So whether they are independent or not, let us check. y1, y2, y1 dash, y2 dash. Find out Wronskian. So e power ax, c e power ax. What is the derivative of e power ax is a e power ax. What is the derivative of e power ax is a e power ax. ad minus bc. ca e power ax e power ax, ca e power ax equals to 0. So Wronskian equal to 0 for all x. What? Because whenever the powers are equal, a, they are not equal independent. If they are equal, we are getting Wronskian as 0, whatever may be the value. So for all x, Wronskian is 0, so they are always linearly dependent on any interval. Next, y1 is sin ax, y2 is cos ax. What is Wronskian? y1, y2, y1 dash, y2 dash. Sin AX is A cos AX. Cos AX is minus A sin A. AD minus BC. Minus A sin square AX minus A cos square AX. Sin square theta plus cos square theta 1, so minus. So they are linearly independent. Okay, so sin AX, cos AX are linearly independent, but e power AX, e power AX are linearly dependent. We have done with the c e power AX earlier. Let us take x e power AX. So y1, y2, y1 dash. What is the derivative of this? A e power AX. What is the derivative of this? This is in the form uv. So u dash v. Derivative of x is 1 e power AX plus x into e power AX is a e power AX. X into a e power AD minus bc. Power AX e power AX plus xa e power AX e power AX minus xa e power AX. Cancel. So e power 2x, which is not 0. So these two are linearly independent. If it is c e power ax linearly dependent, that is, for example, you may be given which of the following are independent. You may be given like this. Are they independent or dependent means? They are linearly dependent. Why linearly dependent? Because e power 2x constant times e power. But if you take a different constant, for example, if I take 3 e power 3x, then automatically these two are linearly independent because the powers are not equal. Even if they are equal, if it is constant times linearly dependent, but whereas if you take x times, then according to this result, they are linearly independent. So even if the powers are equal, if it is not constant times x times, then automatically they are linearly independent. So such questions, by looking at them, you can do, provided you follow this concept. So very important results are, whenever e power ax, e power bx, whenever they are constant, different constants, automatically independent. If they are same constants and one is scalar times the other, linearly dependent. If they are trigonometric, then automatically linearly independent. E power ax, x e power ax. Then in that case, if it is multiple of x, what is the difference between this and this? Here constant, here x times. Then we got linearly independent. Let us see with the three functions. 1 x and x square. 3. How to do with 3 functions? Wronski. y1, y2, y3, y1 dash, y2 dash, y3 dash. Again differentiate y1 double dash, y2 double dash, y3 double dash. 1 x square, 0, 1, 2x, 0, 0, 2. Find the determinant e raised to which is not 0. Therefore linearly independent. So we are going to use all of them for getting the general solution. I'll show you where we are going to use. So definite one question from this area was, not only these functions, you may be given any other functions. Find out the Wronskian. If it is not 0, independent. And if it is using Wronskian, if it is not equal to 0, linearly independent. Wronskian is 0, then linearly dependent. Okay? Now, auxiliary equation. What is meant by auxiliary? Why did we suddenly turn our from there to Wronskian? Is we are going to use while describing complementary function. So first we define what is called as the auxiliary.
Excuse me, ma'am.
Yeah.
Ma'am, in the Wronskian function, are there any other forms, ma'am?
No, only one Wronskian.
Okay, ma'am.
Wronskian you can use for any number.
Like, is there any other formula to use other than this determinant I'm asking?
No. Only determinant.
Okay, ma'am. Thank you, ma'am.
Only determinant. Maybe in the expanded form they may give in textbook. For example, AD minus BC, y1, y2 dash minus y2, y1 dash. Maybe expanded form.
Okay.
So for example, for 2 by 2, y1, y2 dash minus y2, y1 dash. You can write in determinant form, or you can write in the form like determinant and expand.
Okay, ma'am. Like in the previous paper, I saw a solution in which the formula is written in some exponential terms, ma'am. So I was asking, is there anything like that?
Exponential.
Yes, ma'am.
That's what, no? We have seen e power ax. Acha, okay.
Formula itself is in exponential terms, ma'am.
You send it to me. I will send
Okay, ma'am.
it
Thank
to
you.
my
ma'am.
WhatsApp after the class.
Okay, ma'am.
Now, auxiliary equation. For f of d on what is auxiliary equation is, see, there is one formula called Abel's formula. Abel's. Is it Saranya is asking?
Yes, ma'am.
There is one formula here, but I thought of discussing it later. Maybe you might have seen this.
Yes, ma'am. Something similar to this, but I don't remember it.
This is what is called. This is what is called as Abel's formula. This I will explain after explaining that. That is the reason I went to the other one.
Okay, ma'am. Thank you.
This is called Abel's formula. Maybe it might be like this. You send it to me.
Okay, ma'am.
Now, what is auxiliary equation is? For f of d on y equal to 0, auxiliary equation means replace d by m. Then f of m equal to 0 will give you what is called auxiliary equation. So then once you solve this, if y1, y2, yn are n linearly different solutions for f of d on y equal to 0, first we are solving homogeneity. That is right side is 0, later we will extend it to non-homogeneity. So if y1, y2, yn are n linearly independent solutions of this f of d on y equal to 0, then the linear combination, why we went suddenly for round scheme? Because if there are n linearly different solutions, it will take a linear combination. What is the linear combination? One scalar, one vector, one scalar, one vector, one scalar, one vector, and add them. Then this is what is called linear combination. So this linear combination also will be a solution for this. And such a solution in the linear combination containing n arbitrary constant for the nth order equation is called general solution. So general solution must contain number of arbitrary constants if the solution is equal to order of the equation. If it is second order, you should have two arbitrary constants. If nth order, you should have n arbitrary constants. So whenever individually y1, y2 to yn are independent solution, then linear combination c1, y1 plus c2, y2, cn, en also will be a solution for this. Okay? And this solution is also called as the complementary function or non-homogeneous. With respect to homogeneous, it is called general solution. With respect to non-homogeneous, this is what is called as complementary. So same solution is the same. With respect to f of d on y equal to 0, it is called as general solution. With respect to non-homogeneous part, it is called as complementary. Given different name in different contexts. Let us see. What is the working rule to get the general solution for f of d on y equal to 0? First, reduce the given ODE to above standard form. That is, even if it is given in the form of d square by dx square, d cube by dx cube, then you need to convert in terms of d, the standard form. First, transform this to the form standard form f of d on y. Then find the auxiliary. What is the auxiliary equation? D by m, that's f of m. Solve it. If it is nth order equation, then you will get nth degree equation. So if you solve nth degree equation, you will get n roots, m1, m2, and mn. Cases arises. Are all of them not equal, unequal, or some of them are unequal, some of them are equal, or some of them are complex quantities? Three cases arises. Case 1. If all roots are different, that is m1 not equal to m2 not equal to mn, then y equal to c1 e power m1x plus c2 e power m2x cn e power mn. These are the solutions. You know that whenever m1, m2, mn not equal, just now we have seen, whenever a is not equal to b, e power ax and e power bx are independent. So we have seen in the previous problem that we are going to use here. because m1 is not equal to m2, m2 not equal to m3 and so on, e power m1x, e power m2x, e power m1x are linearly independent. Why linearly independent? Because they are all different. So the linear combination c1 e power m1x plus c2 e power m2x and so on up to cn e power m1x is also a solution according to this concept. Whenever y1, y2, yn are independent solutions, then the linear combination is also an independent. It's also a solution. So we can use that because e power m1x, e power m2x and so on, e power m1x are independent because they are not equal. m1 not equal to m2 and so on not equal to mn. We get that c1 e power m1x, c2 e power m2x, cn e power m1x is general solution of this equation f of t and y equal to 0. So linearly independent solutions are because e power m1x, e power m2x, e power m2. So whenever you are given general solution, the coefficients of c1, c2, cn gives linearly independent. In the general solution, the coefficients of c1, c2, cn gives linearly independent solution. Suppose they are equal, m1 equal to m2 equal to and so on, mk plus 1 and so on, and then these are the roots. That is, k roots are equal. Then the general solution is given by c1 plus c2x plus and so on, ck x bar k minus. Because we have seen earlier, if you take same c1 plus c1 e power m1 and c2 e power m2, they are whenever the powers are equal, they are linearly dependent. But we want independence. So what we have observed is, whenever the powers are equal, then e power ax and x e power ax if you take, they are linearly independent. So when the powers are equal, one should be the polynomial times the other, then they will become automatically linearly independent. Therefore, whenever the polynomial is repeating k times, we must take the solution as c1 e power ax plus c2 x e power ax, because they are linearly independent. The c3 x square e power ax. Like this, we must take ck minus x to the power of k minus 1 e power ax. So if you take e power ax common, then this reduces to c1 plus c2x plus ck x bar k minus 1 e power m. So whenever the roots are equal, then e power ax, x e power ax, x square e power ax, they are linearly independent, we have seen. If they are simply a constant time, then linearly dependent. If they are x times, then automatically linearly. Therefore, this solution is also a solution for the homogeneous. It is containing how many arbitrary constants? C1, C2, ck plus 1 up to cn. Therefore, we say this solution is general solution. So, what are the independent solutions here? You can see the coefficient of C1, if you multiply inside e power m1x, multiply this inside x e power m1x, multiply this inside x power k minus 1 here e power nk plus 1 and so on, and then these are all linearly independent solutions. So this combination gives what is called general. Next, suppose they are complex combinations, very important. Then in that case, for second order, let us see. Second order, only two roots will be there. Alpha plus I beta, alpha minus I beta. Then how to write? Your teacher might have told in your degree course, e to the power of real part. What is alpha, real part? What is beta, imaginary part? E to the power of alpha x into c1 cos beta x plus c2 sin beta x. So we have to take like this. What are the independent solutions? E power alpha x cos beta x, e power alpha x sin beta x becomes linearly independent solution. Or most of the physicists, they don't take like this. Mathematicians take physics in your mathematical physics book. You find like this. So they take because alpha minus I beta, alpha plus I beta different. If they are different, then how we will take c1 e power alpha minus I beta into x plus c2 e to the power of alpha plus I beta into x. So linear. What are the linearly independent solutions? Here I have given e power alpha x cos beta x, e power alpha x sin beta. Then somebody may get it down. How did we get this step? How these two are seen? So you know that when m1 is not equal to m2, C1 e power m1x, C2 e power m2x is general solution. Here we can simplify this. How these two are equal, let us see. So you might have taken trigonometric in your courses, but now I am saying newly you take like this. Then is there any difference or are they one and the same? If so, what is the relation? Let us see. So let us take here, simplify. Here you have e power alpha. C1 e power alpha here. Minus I beta. This is e power alpha x, e to e power alpha x plus I beta. E power alpha x, I beta. Take e power alpha x common. Then what will we get if you take e power alpha x common? C1 e power minus I beta x, c power I beta. You know, C1 e to the power of I theta is cos theta plus I theta, minus I theta is cos theta minus I sin. So, what is y equal to? This is nothing but e to the power of alpha x. Y is equal to e to the power of alpha x. C1 e power minus I beta x, that is cos beta x minus I sin beta x. Plus C2 e power I beta x cos beta x plus I sin beta. Take common, C1 cos beta x comes common, you will get C1 C1 plus C2 e power alpha x, C2 C1 e power alpha x cos beta x, C2 e power alpha x cos beta. That means you can club them together and write it as e power alpha x C1 plus C2 into cos beta. So you will get the solution as e power alpha x cos beta x common, C1 plus, you know, C1 is constant, C2 is constant. Sum of two constants is again a constant. So you can call that constant as C1 or you can call that constant as capital B. In some textbooks they use B. So e power alpha x a cos beta x plus b sin beta x. So if you take sin beta x coefficient, get e power alpha x sin beta x into here. What did we get? E power minus I. So here you will get I terms minus C1I minus I. This is nothing but a constant. I times a constant is constant. So that we are calling it as. So when you expand and simplify, if you expand and simplify this, you will get back the same exact. If you simplify this, applying de Moivre's system, e power alpha x, e power minus beta x, e power alpha x into e power beta x. So e power alpha x into cos beta x minus I sin beta x, plus C2 e power cos beta x plus I sin. So linearly independent solutions are. So you can write either this or this. Both are. Suppose they are repeating. Then how we are going to write this? When they are repeating two times, we have to write first degree polynomial. Where to write is here, cos beta x coefficient polynomial sin beta x. Or you can also write it as C1 plus C2x e power alpha minus I beta into x, C3 plus C4x into e power alpha plus I beta. Linearly independent solutions are the ODE. No problems based on this. Let us see. So we have three cases now. What are the three cases? If they are different, then e power m1x, c1 e power m1x plus e power m2x. If they are equal, if they are repeating two times, first degree polynomial. Again, if they are complex conjugates, then e power alpha x plus c1 cos beta x plus c2 sin beta. So let us see. Linearly independent solutions of the ODE are. First, what is the first step as we have discussed? You may be asked to find what are the independent solutions of this, or you may be asked to write what is the general solution of this. In either of the cases, we need to solve like this. First step is, first we have to transform them to D form. That is in terms of D. This is D cube plus 9D on y equal to 0. D cube plus 9D on y. Because D cube on y is y triple dash, D on y is y dash. What is the auxiliary equation? M cube plus 9m equal. Take m common, m into m square plus 9 is 0. M equal to 0, m square equal to minus 9, that is m is root minus 9, which is plus or minus 3. So m equal to 0 and m equal to 0 plus or minus 3. So what is the solution for this? Y equal to c1 e power 0x plus e power 0x c2 cos 3x plus c3 sin. E power 0x means 1. E power 0x 1. So c1 plus c2 cos 3x plus c3 sin. So what are the independent solutions? c1 coefficient is 1, c2 coefficient is cos 3x, c3 coefficient is sin 3x. So what are the independent solutions of this? 1 comma cos 3x comma sin 3x. I'm repeating once again, please. First reduce it to standard form. Triple dash is there, we get d cube. Double dash means d square. Then write the auxiliary equation. This is f of d. Replace d by m equality to 0. Then we get what is called auxiliary. Solve this equation. Take m common. M into m square plus 9 equal to 0. M is 0. M square is minus 9. M is root minus 9 plus r minus 3. M equal to 0 comma 0 plus r minus 3. So here this root for this is m1 c1 e power m1x plus this is in the form alpha plus r minus I theta. That means e to the power of alpha x according to definition. Whenever you get like this, e power alpha x c1 cos beta x c2 sin beta x. What is alpha? Real part. What is beta? Imaginary part. I coefficient. So if you e power 0 is 1, if you multiply inside, then you will get c1, c2, c3 coefficient. c1 coefficient is 1, c2 coefficient e power 0 is 1, so cos 3x, c3 e power 0 is constant sin. So what are the three linearly independent solutions? 1 comma cos 3x comma sin 3x. Next is fourth degree. How to fix? So d power 2 plus fourth degree to d square because second order plus y equal plus 1 equal to 0. Y means y only. Now auxiliary equation is given by m power 4 plus 2m square plus 1 c. You can rewrite it as m square plus 1 whole square equal to 2. That means m square equal to minus 1 2 times because the form is 2. M equal to root minus 1 root minus 1, that is plus r minus I plus r minus 3. Now, how to write down complementary function for them? They are repeating 2 times. Minus 1, that is plus r minus I plus r minus I. Alpha plus r minus I. Here what is alpha? Real part. There is no real part, that means 0. What is beta? I coefficient 1. It is repeating 2 times. If it is repeating 2 times, as we have discussed, we should go for first degree polynomial. That is e power 0 is 1, c1 cos x plus c2 x cos x, c3 sin x, c4 x sin. So what are the 4 linearly independent solutions? Cos x, sin x, x cos x, x sin. These are 4 linearly independent solutions. Next we have y power 4 plus 16 y double dash. That means d power 4 plus 16 d square on y. So what is the auxiliary equation? M power 4 plus 16 m square. Take m square common. Get m square plus 16. M square 0 means m equal to root 0. That means 2 times 0. m square equal to minus 16. M is root minus 16. What is root of 16 plus r minus 4? Root minus 1 is answer. Now, here this is repeating 2 times, this is only occurring once. So let us see, 0, 0. That is, this is repeating, 0 is repeating 2 times. So first degree polynomial. C1 plus C2 x into e power 0x. Next, e power 0x, alpha x, C3 cos 4x plus C4 sin 4x. Multiply inside e power 0 is 1, e power 0 is 1. So what are the 4 linearly independent solutions for this? They are nothing but C1 plus C2x, C3 cos 4x, C4 sin 4x. So C1, C2, C3, C4 coefficients will give you general solution. Here C1 coefficient is 1, here x, here cos 4x, here sin 4x. So they are the linearly independent solutions for this. D cube minus d square minus d plus 1 on y. 3 plus d by m cube minus m square minus m plus 1. So here we apply, luckily m square common, so m square into m minus 1, minus 1 common, m minus 1. M minus 1, m minus 1 common, so we get m minus 1 into m square minus 1 equal to 0. So m is equal to root 1 plus r minus 1, m equal to 1. So what are the roots? 1, 1, minus 1. So 1, 1 repeating 2 times. So how will we write the complementary function? C1 plus C2x, e to the power of 1x plus C3 e power minus 1.